Today we will discuss about the logistic distribution. Logistic distribution. Logistic distribution को define करते हैं. So first we define the distribution function, then we define the logistic distribution when we can write out the probability density function of that. So now this logistic distribution is also a continuous probability distribution. So we basically write down as a continuous random variable. A continuous random variable x is said to have a logistic distribution with parameters alpha and second parameter is beta. So the distribution function is of the form. So we write down the distribution function as fx. Fx is equal to 1 plus e raised to the power minus x minus alpha upon beta whole to the power minus 1. Here we take beta as greater than 0. This also written as 1 by 2 1 plus 10 hyperbolic 1 by 2 x minus alpha upon beta. So here we can write down beta greater than 0. So what is the alpha and beta here? So alpha or beta basically define the shapes of the distribution. So two parameters we can write down here as two parameters alpha, beta define the shape of the distribution. First we write down as the location parameter. Location parameter we have alpha. So this shows that, so we can write down tells us where it's centered as x-axis, and the second parameter, that is beta, which work as a scale parameter. तो दूसरा पैरामीटर हमारा that is beta, which work as a scale parameter. Now अब इसके बाद हम लिखते हैं इसका probability density function. So the probability density function, the probability density function, in short we write down PDF for the distribution is e raised to the power minus x minus mu upon sigma 1 plus e raised to the power minus x minus mu upon sigma to the whole square, where the random variable x which lie between minus infinity to plus infinity. So ये इसका probability density function we involve here as mean mu and variance sigma. basically two parameters for the PDF. Generally, we write down the two parameter in distribution function which are taking alpha and beta. Now, where we use this logistic distribution, so we can write down the uses of this. So, logistic distribution is to formulating, used basically used for modeling growth and also for logistic regression. This is the symmetrical distribution. Also, we can say that this is unimodal. Unimodal means having only one peak, having only one peak. And this has the similar shape as the normal distribution. और इसकी जो shape होती है बिल्कुल exactly similar to the normal distribution. क्योंकि normal distribution is also having the one peak, or also the unimodal, also the symmetrical. So same behavior of the logistic distribution as the normal distribution. और इसको कहाँ यूज करते हैं बेसिकली, तो वी कैन राइट डाउन द यूजेस ऑफ दिस. So the logistic distribution is extensively used on growth function, growth function of population and demographic studies. Demographic studies and time series analysis. So basically we use for the population growth, demographic study and time series analysis. So the logistic distribution can be obtained as the limiting distribution as n tends to infinity of the standardized mid-range coverage of smallest and largest sample observation. Smallest and largest observation in random size of n. Or second, a mixture of extreme value distribution. Mixture of extreme value distribution. Now we talk about the standard logistic distribution. So for a standard logistic distribution, we have mean, which is alpha, and variance, we have this is mu2. Mu2 is equal to, we can obtain as pi square upon 3 into sigma square, and beta 1, which is mu3 square upon mu2 cube, that is 0, and beta 2, which is mu4 upon mu2 square, this is 7 into 9 upon 15, which is equal to 4.2, equal to 4.2. This is skewness and coefficient of skewness. So here we write down as mu is decrease. Mu decrease. So the PDF is shifted to left, or mu increase. So the PDF is shifted to right. अगर ये डिपेंड करता है म्यू की वैल्यू पे, अगर म्यू इंक्रीज हो रहा है तो हमारा जो पीडीएफ होगा वो शिफ्ट करेगा राइट की तरफ, और डिक्रीज हो रहा है तो विच विल शिफ्ट टू द, so here is t, this is ft, and suppose we are drawing the graph, so this is the first shape. Here we have mu equal to 10, और जब mu की वैल्यू डिक्रीज कर देंगे, so suppose we are increasing the value of mu, so we are shifting PDF to the right. So mu is 15, and the 17 or 13, 30 jai, that will be also shifted to the right side. So this can be represented as effect of the logistic distribution. So this is effect of the logistic distribution. So because we are defining that this is having sharp peak, that means only unimodal single peak. Now अब इसको basically use कहाँ करते हैं, so that we define as application part. So application of this distribution. So for writing the application, so first we use for market penetration of new products. क्या क्या products की launching हो रही है, so we have do the survey type. Now second, we can use this distribution for using the population growth. Third, we can use this distribution, the expansion of agricultural production. How to increase the production? So we are basically used for expansion of the agriculture. Weight gain in animals. Weight gain in animals. So these are basically applications for the logistic distribution where we apply this. Now, अब इसके बाद हम चलते हैं लॉजिस्टिक रिलायबिलिटी. लॉजिस्टिक रिलायबिलिटी function. For logistic reliability function, we define as the reliability the reliability for a mission of time t starting at is 0 for logistic distribution is defined as RT equal to T tends to infinity, FTTT. So here T represent the time, or we can define this RT. This RT is equal to 1 upon 1 plus e raised to the power Z. So this is for reliability or unreliability function. So non-reliability means basically, so we can say that the Ft equal to 1 minus RT. So Ft equal to 1 minus RT, the 1 minus 1 upon 1 plus e raised to the power Z. So this can be written as e raised to the power Z upon 1 plus e raised to the power Z. So here we write down Z. Z is equal to x minus mean mu upon standard deviation sigma. So this is for the unreliability. That means Ft we can defined as 1 minus RT. Okay, so hope you understand about this logistic distribution probability density function and logistic reliability function.